Kia ora Year 12 and Year 11. This video is going to go over the revision question I put up on the board yesterday, which was an exponential problem. And we've got words here, we're going to have algebra, and then we're going to look at the graphs for the two situations. So your auntie gives you $500 and she tells you to put it into bank A at an interest rate of 3.5%, compounding annually. So that means that the interest gets put back in the bank and reinvested. And we've looked at this in class before. If you can't remember how that works, go look at the video about the cockroaches in the laundry. The formula that we're going to use to solve problems like this is this one here, which is P, which is a really stupid letter to use for the future amount. We've got P is equal to A times R to the power of N, or sometimes you'll see P is equal to A times R to the power of T. So what are the things that are going to determine how much money we'll have after 5 years? Well, it's going to depend on how much we were given, and then it's going to depend on the interest rate. And we know that it's going to be N equals 5. So that's quite an easy problem. The harder one in here is to work out how long it will take to have $1,000. So we'll do that one first, then we'll come back to the next one about our uncle. So the initial amount is what she gave us, which was $500. And we're going to invest it for 5 years. So N will be 5. Well, we want to know how much we'll have after 5 years. And the interest rate is 3.5%. So that means that the growth rate that we're using will be 100% plus 3.5%. And that equals 1.035. Now, the 100% is saying that we take what we had and then we increase it by 3.5%. This is just what we learnt to do back in year 10 when we were doing increasing by a percentage. So after 5 years, she will have your $500 times 1.035 to the power of 5. And that works out to be 593.8432, which is a very silly answer. So we can round that. Probably easiest to round that to the nearest cent, and then just state that we've done that to 2dp. I think it would also, in this case, be fine to round it to the nearest dollar and say that's to 3 significant figures. Okay, so that's the first part done. The second part, how long will it take you to have $1,000? So we're going to use the same formula, but this time what we're trying to solve for is the number of years. So we know this thing here, and this thing here. We're going to need to use logs. So on the left-hand side, we have $1,000. And on the right-hand side, we have this. So 500 times 1.035 to the power of n. The first step is to divide through by the 500. That leaves us with 2 is equal to 1.035n. So what we're asking is how long it's going to take for her money to double when the interest rate is this. So that's why that 2 should make sense. Okay, let's take logs of both sides because we have a power that we're trying to solve for. So log of 2 is equal to the log of 1.035 to the power of n. And we know our 3 log rules. So the log of a to the power of b is equal to b log a. So here we've got log 2 is equal to n log 1.035. So finally n is equal to the log of 2 over the log of 1.035, which gives us 20.14879. So how long will it take us to get to $1,000? It will take more than 20 years. It will take us 21 years to have $1,000. Okay, because the amount is compounding every year, so after 20 years we will be slightly short of $1,000. Right, let's look at the graph of this now and see what it looks like. So this is our first example that we've seen this year of an exponential graph, but you'll probably remember them, hopefully, from level 1. You can see here that our starting amount when x equals 0 is our $500. And we can check our answers in here. So after 5 years, 1, 2, so here's 5 here, we can see that we haven't quite got to $600. And after 20 years, we can see that the amount is just about exactly 1,000. So that point is 20.14, blah, blah, blah. Okay, let's look at the second question. So this one is quite similar for the first part, but I've added in a part where the value of a car is depreciating or going down. So your uncle gives you $4,000 and you put it in the bank at 5%. I haven't written that it's compounding annually, but that's what we'd assume. After 20 years, you take your money out of the bank to buy a car. So how much money will you have to get the car? Well, that should feel pretty easy now. So P is going to equal the $5,000 that he gave us. Let's just check it was $4,000, sorry, $4,000. So P is equal to 4,000. The interest rate's a little bit better, so it's times 1.05. We were asked to look at what it's worth after 20 years, because that's when you decide to take the money out. So it's going to be times 1.05 to the power of 20. That gives us $10,613.19. And we assume that he finds a car for exactly that amount of money. Right, now what's happening with the car is different. The car's value decreases at a rate of 15%. Now, I should have said in there at an annual rate of 15%. Okay, so every year the car is worth 15% less than the year before. So that means that in my formula here, the R is going to be 100% take away 15%. That gives me my decimal of 0.85. I think for most of you in the class, you are getting from this part of the question to this part very, very quickly, and that's really good. So what will the car be worth 3 years after you buy it? Well, we started with a car that was worth $10,613.19, and after 3 years, it's going to be worth this much. $6,517.83. And what I've asked you to figure out is how long it's going to take for the car's value to come back to the initial $4,000 that your uncle gave you. So that's similar to the last part of question 1. This is the equation that we're trying to solve. The final value is going to be 4,000. The starting value that we paid for the car is this much, and it's depreciating at 15% a year. So we have to figure out how many years it will take for the value to drop to 4,000. So we divide both sides through like this, and then we take logs of both sides. You can put these numbers into your calculator earlier. But I'm just going to leave it like this. And I'll do it a bit slower here. So again, we've got log of 0.85 to the power of n. That's the same as n log of 0.85. So n is equal to the log of this divided by the log of 0.85. Now you'll notice that both of these numbers are negative, and that's what's often going to happen in problems with depreciation. So our final answer here is that n is equal to 6.004 years. So that's so close to 6 that I would say after approximately 6 years, the car will be worth $4,000. So there you go. Hope that helped. There are lots of those problems to practice in the Walker workbook and in theta, and they do come up in the exams all the time. Thanks for watching.